This is the tutorial for Chapter 2, Section 5, and it's titled Similar Figures. And so we know figures are similar if the corresponding angles are congruent. So congruent, what that means is that they're exactly the same. So the angles are equal. So for instance, if this is angle A, and this one is angle D, let's say, I would say, and they are similar. If they are, then angle A would be congruent. And they show a congruent symbol with an equal sign and tilde on top. And it's congruent to angle D. So corresponding angles have to be congruent, exactly the same. And the corresponding sides are proportional. So proportional just means that we have ratios that equal. So we'll say ratios that equal one another. And so that's what we're going to end up doing, is really setting up those ratios to see if they're equal. Because we can have figures that have the same angles but are not proportional. The corresponding sides are not proportional. And we might see that in these examples. So this one tells us one angle. We know this angle here and this angle here are both 90. It doesn't give us any other information about these two angles here. So we can't use this rule right here, but we can check to see if the sides are proportional, and that's what I'm going to do. So I need to look for corresponding sides, and I'm going to set up ratios. So I see that this side right here, that's 20, corresponds to this side, that's 4. So I'm going to set up a ratio of those two sides. 20 is to 4. Then I'm going to do the same thing for some other ones. I'm going to do this one, 15 and 3. So I see that another set of corresponding sides is 15 to 3. And I'm going to see if they equal one another. Because if the ratios are the same, like this one is 25, and the other triangle has a corresponding side that's 5. If the ratios of corresponding sides are proportional, then that means that they will equal one another. And I see that. See, this one would reduce down to 5 to 1. This reduces down to the same thing, 5 to 1. And you see 25 over 5 is the same thing, 5 to 1. So this is called proportional, where proportional just means the ratios are equal to one another. And we see that. So we would say, yes, the triangles are similar because the corresponding sides are proportional. So when we take a look at the next one, we see that we have some angle symbols. So this angle here means that it's the same as this angle because they have the same markings. And this angle here is the same as this angle because they have the same markings. And we see those on this image here. We have these two angles are congruent, just as they're the same as these angles as well. And so if we flip this over, if we reflect it, it would match up so that this side and this side would end up matching up. So I would say that 9 and 5 are corresponding. So I see the angles are the same, the corresponding angles are the same, but we need to check for the sides to be the same as well. So I'm going to set it up this way. 9 is to 5. So those two sides are corresponding, so I'll write a ratio of those two sides. I want to see if they equal the corresponding sides from the other set of sides, or the corresponding sides of 12 and 8. So I started with 9, so I'm going to put 12 on the top. I'll put 8 on the bottom. And when I look at these, I'm not sure if they're the same. So you can always reduce to see if they're the same. Another way is using cross products. Use cross products. And so we can use these to check, especially when the numbers are a little bit more difficult, if they have decimals, and it's tough to reduce those fractions. So let's try this. If I go ahead and cross multiply the 5 and the 12, so 5 times by 12, I'll set that equal to 9 and 8 being multiplied, 9 times by 8. So this gives me 60, and this gives me 72. So I see those two numbers do not equal, so they are not proportional. So I would say not similar, because the corresponding sides are not proportional. So let's take a look at another problem, and it says that in a classroom a dry erase board is 8 feet long and 4 feet wide. So 8 feet long and 4 feet wide. And so this is 8, this is 4, and the key is looking at the words they use after the numbers. So long, wide. And those are going to be the ones that you really got to look for. I use the little dash up top to represent feet. Teacher wants to make some individual dry erase boards for use on the student's desk. They are 11.5 long by 9.5 wide. So 11.5 inches, so 2 marks for inches, long, and then they are 9.5 inches wide. So notice that the key is looking at those words. So I know that these two sides are going to be corresponding, and these two sides are going to be corresponding. So what we do is we set up a proportion. So I go ahead and write that as 8 is to 4 as, and then 11.5 is to 9.5. So you see how when I set it up, I started with just two numbers from the one figure. And so I did 8 is to 4. And then if I do that, I need to make sure the corresponding sides go in the same location. So 11.5 corresponded to 8, so I put that in the same location in the fraction. Same thing with the 9.5 and the 4. So we're ready to multiply. So I'll cross multiply to check to see if these are the same number. 8 times 9.5, and then I'm going to see if that equals 4 times by 11.5. Well, we'll go ahead and punch those numbers in the calculator, and I see that 8 times by 9.5 gives me 76. And it makes sense because 8 times 9 is 72, half of 8 is 4, 72 and 4 makes 76. So let's check the other one. We have 11.5 times by 4, and that gives me 46. And that makes sense too, because 4 times 11 is 44, half of 4 is 2, 44 and 2 do make 46. And those two numbers do not equal, so they are not similar. And again, stating that reason, so not similar because the corresponding sides are not proportional. So let's take a look at the next one. It says that you have a 4x6 photo. So here's our photo. Let's say this is 4, this is by 6. And you order a 5x7. Let's order one that's just a little bit bigger, 5x7. Is the new photo similar to the first? Well, again, you're just setting up a ratio. 4 is to 6 as, and then 5 is to 7. And so when I go ahead and try to cross multiply, again I did 4 is to 6, and then I took the corresponding sides, and we see if they equal. So this makes 28. 6 times 5, that makes 30. We see that they are not the same, so not similar. And the reasoning is the same. The corresponding sides are not proportional. Well, here it says you enlarge the photo 3 times its size on the computer. Is the photo similar to the original? Okay, so here's the photo, 4x6. We enlarge the photo by 3 times the size. Alright, so 3 times the size means that each of these sides is getting bigger by 3 times. So I'll times this side by 3, times this side by 3. So that would give me a 12x18. So this side is 12 and this side is 18. Are those proportional? Well, yes, they are. Now here's how. I can prove it by just taking those numbers. 4 is to 6 as 12 is to 18. So you see if I go ahead and cross multiply, 4 times 18 gives me 72. And when I cross multiply the 6 and the 12, I get the same numbers. 6 times 12 is also 72. So why did it work? Well, it's because I multiplied both numbers by the same value. Multiplied both of them by 3. And so when I'm increasing a number, as long as I increase both sides by that same number, multiplied by that same number, you'll get proportional figures. So let's take a look at one other type of problem, and I think I'll do it, just draw one for you here. that you might end up seeing. So let's say we have a situation like this. Let's go with a tree. And so this tree here is standing up, and it's, let's say, dead now, and we want to cut it down. So we want to find out how far will it end up falling. Will it end up hitting like a house or something like that if we go ahead and cut it down? Well, what we are not sure about is how tall it is. So let's go ahead and let's measure. It's on flat ground, and one day the sun is up above it, and we go ahead and we measure this or the shadow's length. And so let me fix the shadow a little bit. So I'll draw that a little bit straighter. Alright, so here's the sun. It's up here, and the sun rays are hitting the tree, and one ray comes down here and it makes a triangle. See how we have a triangle there? And so what we can end up doing is figuring out how tall it is if we add another triangle inside. So this is the shadow. This is the tree's shadow. This is the sun ray here. And let's say you take a person and you go ahead, or maybe like a stick or something like that, like a little rod. Let's say it's 4 meters high. We know the rod is 4 meters. And we place it so just the sun is just touching the top of it. So we know that it is kind of in line with this sun ray. So I measure the distance from, let's say, the tree to the pole. And that distance is, let's go with about 15 feet, or 15 meters. And then I measure the distance from the pole to the end here, and that is 6 meters. And so now I've got enough information to find the height. And what I can do is I can use proportions. So notice how we have a couple triangles in here. We've got the big triangle here, where the tree is, and then this part right here, that's the big triangle. And that triangle, if we take it out and we redraw it, we can write down some sides. We want to find the height. Not sure what that side is, but we know this entire length. This length is 15 plus 6. So that length is 21 meters. And then we know the other triangle. We know a little bit more about its information. We know that this length is 6 and this length is 4. So we've got enough information to solve for x. The way we do that is we set up a proportion. Let's do it this way. X is to 21 as 4 is to 6. See, x and 21, and then I took the corresponding sides and put them in the same location. 4 corresponded to x, 6 to 21. So I'm ready to go ahead and solve. Now, one thing I'm going to do is I'm just going to reduce this fraction a little bit. Sometimes I can do it in my head if I can make the numbers small enough. So I'm going to reduce that. So I still have that x over 21, but I can reduce this fraction to 2/3. And it helped me a little bit because now the numbers are a little smaller. So I'm going to cross multiply. I got 3x equals, and then 21 times 2, and that gives me 42 equals 3x. So now I'm ready to divide. Divide by 3, and I see 3 does go into 42 evenly. 3 goes into 4 one time, and then with 1 left over, 3 goes into 12 4 times. So there it is, 14 meters. That is the height of tree. Height of tree. And so there we have it. So on some of the problems you will be solving for unknowns. So you just need to look for the corresponding sides and make sure they go in the same spot of the fraction. Well, those are problems you'll see on homework from Chapter 2, Section 5. Good luck.